This is section 6.5, the dot product. In the previous section, we learned that scalar multiplication, vector addition, and vector subtraction all produce answers that are vectors. In this section, we're going to learn a new operation on vectors that produces a scalar solution. This new operation is called the dot product, and some alternate names for this are the scalar product or the inner product. So the way it's defined. So for two vectors, v, which is v1, v2, and w, w1, w2, the dot product of v and w, which is denoted v dot w, this is why we cannot use the dot for scalar multiplication, is defined as, here we have it written in this form, and basically you multiply your two first components plus you multiply your two second components to get your answer. So looking at this example, if the vector u is defined to be -1, -2, and v is -3, -4, then u dot v is equal to multiply your first components, -1 times -3, plus multiply your second components, -2 times -4, and you have 3 plus 8, and your answer is the scalar number 11. Here, we're given our vectors in a different notation, and you know how to change this into a position vector. This would be 6, -1, and this is 2, 7. Most of the time, we don't actually go ahead and write it this way because we can just multiply our first components are going to be our I values. So u dot v is equal to your first components multiplied together, which are your I values, 6 times 2, plus your second components, which are your j's, -1 times 7, and we have 12 minus 7, which is 5. So the dot product of these two vectors is equal to 5. Okay. The dot product and the angle between two vectors. If theta between 0 and 180 is the angle between two non-zero vectors v and w, then the dot product of those two vectors is equal to the magnitude of v times the magnitude of w, these are going to be scalar values, times cosine of theta, which is also a scalar value. Or solve this for cosine of theta if you're going to be looking for your angle value, and it's simply v dot w divided by the magnitude of v times the magnitude of w. So let's say we want to find the dot product of u and v, and theta is the angle between v and w, and we want to round our answers to the nearest tenth if needed. If I want to find u dot v, this is equal to the magnitude of v and w. Basically, here it's v and w, here it's u and v, but it doesn't particularly matter. You're going to multiply these two magnitudes together. So 3 times 4 times cosine of pi over 3. Now you need to be in radians because this does not have a degrees on it, so make sure you're in radians before you do any of these calculations, or this is one you should know. It's 3 times 4 times 1/2. So this dot product is 6. This was exact, we don't need to round. Okay, now let's do the same thing here. I want to use these values for u, the magnitudes of u and v, and my new angle is 78 degrees. So the dot product of u and v will be these two magnitudes multiplied together, 5 times 3 times cosine of 78 degrees. Now this is not an exact value. You want to make sure that you are in degrees here before you do any calculations. 5 times 3 times cosine of 78 degrees is approximately 3.1. So the dot product of those two vectors is 3.1 approximately. Now let's find the angle between two given vectors. And in this case, I'm going to be using the alternate version of the formula, which was cosine of theta is equal to v dot w over the magnitude of v times the magnitude of w. Okay? And then we'll be able to take inverse cosine of this to find our theta. So let's start off with v times w, or v dot w. And this will be -1 times 5, -5, plus 1 times 12, which is 12. So this will be 7. Okay, now the magnitude of v is the square root of -1 squared, which is 1, plus 1 squared, which is 1. So this is the square root of 2. Okay, the magnitude of w is the square root of 5 squared, which is 25, plus square of 12 squared is 144. And this gives us the square root of 169, which is 13. So cosine of theta is equal to 7 over 13 times the square root of 2. So find inverse cosine. Your theta is going to equal inverse cosine of 7 over 13 square roots of 2. We're asked to find our answers to the nearest degree, so make sure that you are in degrees. Inverse cosine of 7 over 13 square root of 2 is approximately 67.6 degrees. Okay. Let's do the same thing here with our v vector as 3i minus 7j and w equal to 7i plus 3j. It's going to be worked exactly the same way. Let's find v dot w first. You can write this as position vectors and then find the dot product, or you can just multiply your I values and then add the multiplication of your j values. 3 times 7 is 21, plus -7 times 3 is -21, which is equal to 0. Okay? Now, technically, you should find the magnitude of v and the magnitude of w. But these really aren't going to matter if the numerator is 0, because 0 divided by anything is 0. So what we have here is cosine of theta is equal to 0. So theta is equal to inverse cosine of 0, which is 90 degrees. Now, we're going to come back and talk about this one in just a bit.